Introduction to Volume, Finding the Volume of Cylinders, Cones, and Spheres. This video goes along with a note sheet. If you have the note sheet or your notebook, open to the correct page, and if not, you could follow along or take notes on separate paper. Volume is the amount of space an object takes up. We often see measurements on the outside of water bottles and other drink bottles. We buy 2-liter soda bottles, gallons of milk, and pints of ice cream. All of these are different units of volume that we see in our lives. You've seen volume in math class before. In 7th grade, you found the volume of rectangular prisms, cubes, and cylinders. For example, this rectangular prism, you would find the volume by multiplying the length times the width times the height. This year, we will be working with spheres, cylinders, and cones. Pause the video and brainstorm a list of at least 5 cylinders, spheres, and cones in your everyday life. Here are some real-life examples. A cylinder is a 3-dimensional shape that has 2 parallel circular bases. It's like a circular prism. Notice that we have graduated cylinders. The word cylinder is in their name. We also have cones, traffic cones, party cones, ice cream cones. A cone comes to one vertex at the top and has one circular base. And then we have a sphere, commonly known as a ball. We have a central point, and every single point on the sphere is the same distance from that central point. Kind of like a 2-dimensional circle, but this is 3-dimensional. It's important to be able to identify cylinders, cones, and spheres in order to correctly find their volumes. The formula for the volume of a cylinder is pi r squared h. R is the radius, and h is the height. Fill this into your box. As a quick refresher, pi, which is represented by this Greek letter, is the ratio of circumference, the distance around a circle, to diameter. It's a constant that always holds true. The circumference over the diameter is always approximately 3.14159, etc. You may have memorized some of these digits at some point. And for our class, we're going to be just using the digits 3.14 in our calculations. Before we move on to look at the other 2 formulas, let's quickly look at the formula for the volume of a cylinder. You should notice that this pi r squared looks familiar. It is the formula for the area of a circle. Notice that a cylinder is really a stack of a bunch of different circles on top of each other. So it makes sense that we would need to find the area of the circle first, and then multiply it by however tall our height is. Now, this connects to all prisms because in any prism, we find the volume by finding the area of one of our 2 bases and multiplying it by the height. Our next formula that you should write down is for a cone. The volume equals 1/3 pi r squared h. Notice that this is 1/3 of the volume of a cylinder. This is our formula for volume of a cylinder, but we're taking 1/3 of it. You could find the volume of the similar cylinder and divide it by 3 if we had the same size base. Our third formula is the formula for the volume of a sphere. Volume equals 4/3 pi r cubed. Make sure that you note that that is cubed and not squared. In our volume formulas for the cones, cylinders, and spheres, we need to use the radius. It's important to remember the difference between the radius and diameter. So if you look up at the top, you can see the difference. The diameter goes all the way across the circle from side to side through the center point. The radius goes from the center point to the outside of the circle, called the circumference. If we are given a diameter instead of a radius in our diagram or in our problem, we simply need to cut that in half because the diameter is twice the radius. This is a good opportunity to quickly discuss what we mean by dimensions and what we mean by units. Some examples of dimensions are length, width, height, and depth. We would use something such as centimeters, inches, millimeters, or even miles to describe a dimension. Similarly, we will use those same units for our radius and for our diameter because they are one-dimensional. For area, we would use the units squaring each of these. For example, centimeters squared. For volume, which is what we'll be working with today, we would have centimeters cubed. If you think about finding the volume of a 3-dimensional figure such as this, we're working in this case with meters cubed because that's how many cubes there are that are a meter by a meter. So each of our units for volume are going to be cubed, centimeters cubed, inches cubed, etc. You also might hear liquid units, not so much in math, but in some of our real-world examples of liters. 1 cubic centimeter equals 1 milliliter. That's just a fun fact, though, not as relevant to what we will be doing. So we've learned the formulas, and we've talked about what the radius is. Now we need to talk about what the height is. When I think of my height, I think of myself standing up and down. However, my height, if I was lying on the ground, I would still be 5 foot 2 inches, even if I'm lying on the ground. So in terms of our shapes here, the height is the perpendicular distance from the base to the vertex on a cone, or the base to the other base on a cylinder. And we don't see a height when we're talking about a sphere. So if we were to label each of these heights, our height would be going from the base to the vertex on this cone. It would be going from the base to the base on this cylinder. It would be going from the base to the vertex on this cone. And notice that I could draw it to the side, or I could draw it in my shape itself. And this cylinder, which we can think of like a can on its side, it would be going from base to base. And again, it might be labeled down here instead. So as you approach each problem, the first thing you need to do is identify what shape is it. Is it a cylinder? Is it a cone? Is it a sphere? Then you need to identify the radius. Notice that some problems don't give you a radius, they give you a diameter. No problem, we can simply cut that in half, and instead of a diameter of 16, we know that the radius from here to here would be 8. Then you need to identify the height, remembering our rules about which direction the height is going. Now we're going to find the volume of some figures. For every problem, you need to include at least these 3 steps. Write the formula, fill in the formula with the numbers that you know, and answer the question. You can use a calculator to reach this. Please don't round until the very last step, and then you need to round to the nearest hundredth. Remember to always include units. Here's the first problem. If yours doesn't match, you can write on separate paper, or you can just follow along. The first thing I need to do is identify which shape I'm dealing with. This has 2 circular bases that are parallel to each other, so I know that I'm dealing with a cylinder. I'm going to copy down the formula for the volume of a cylinder. Notice that we always write an entire equation with both sides. That means you need to write the V equals. Now, in my formula, I have 3 unknowns. I have V, volume, I have R, radius, and I have H, height. I'm going to fill in what I know. I don't know the volume. I know that the diameter is 4 because this red line goes all the way across. That makes my radius halfway across, and that's 2. And my height is given, and that's 6. I will now fill that into the formula. Instead of pi, I will write 3.14 for all of my calculations. If you have a pi button on your calculator, your answer will actually be more accurate, but so that our answers match, I would ask you to use 3.14, unless your teacher tells you otherwise. And using a calculator, I get 75.36. I know that since my units originally were meters for each dimension, my volume would have meters cubed as its unit. So I've included the 3 steps that are necessary: the formula, the work filled in, and my final answer. Now it's always good to double check your answer with estimation because many of our mistakes come from typing things in wrong on our calculator. So to estimate this problem, I have pi, which is about 3, times my radius squared, and I know in my head that 2 squared is 4, times my height, 6. When I multiply these together, I have 3 times 4, which is 12, times 6, which is 72. That's very close to 75, especially since I took 3.14 and changed it into 3. Therefore, I know that my answer is probably correct. You also might see, especially later in high school, answers given exact. Now, exact means that we wouldn't want to round pi, so you would actually leave your answer as 24 pi. Don't worry about this so much this year, but notice that that comes from 4 times 6, and we would leave pi as it is. Let's do another example. If you're feeling good, I would encourage you to pause the video and try this on your own. We can follow the steps, just like always, of identifying the shape, writing the formula, filling in the formula with numbers, and finding the answer. If you're unsure how to do it, follow along with me. The first thing we need to do is identify the shape, and I know this is a cone because it looks like a traffic cone or an ice cream cone. In other words, we have a vertex at the top and a circular base. Then I need to write down the formula. So my volume equals 1/3 pi r squared h. And as always, I will write my variables over to the side. V for volume, r for radius, h for height. I again don't know the volume, but I do know that the radius is given, and that's 3, and my height is 5. So I can fill in my formula and use a calculator to find my answer. I find that my volume is 47.1 units cubed, or cubic units. One thing that I would suggest is, when possible, you do the squaring in your head so that you don't mess anything up. So in my calculator, I would type in 1 divided by 3 times 3.14 times 9 times 5. Or I would type in 3.14 times 9 times 5, find that answer, and divide it by 3, because that's the same as multiplying by 1/3. As always, we want to check with estimation. So I have 1/3 times about 3 times about 9, or exactly 9, times 5. Since those will cancel, I'm going to get approximately 45. So I know that my answer was correct. Let's do another example. Depending on the version of the notes you're using, it may not be example 6. So find this shape that has the 10 across it. I can identify that this shape is a sphere because it looks like a ball. My formula for the volume of a sphere is V equals 4/3 pi r cubed. Remember that that's cubed. So I need to figure out, do I know the volume and do I know the radius? I don't know the volume, but I know that the radius is going to be half of this 10, so it's going to be 5. When I fill that in, I get volume equals 4/3 times 3.14 times 5 cubed. Hopefully you know that 5 cubed is 125. When you type this into a calculator, you want to type in 4 divided by 3. And when you find the entire volume, if you've used 3.14 for pi, you would find 523.3 repeating feet cubed. You can leave that as your answer, or you could leave it exact as 523 and 1/3, or if it asks you to round to the nearest hundredth, we would write 523.33. Although that's rounded, that would be an acceptable answer. Make sure you include your units, feet cubed. To summarize what we've learned so far, the first step is to read the problem and underline what is being asked for. Today we only looked for problems that we're solving for the volume, but we might find a problem that's asking for the height or the diameter or the radius or something else, especially in a real-world problem. Then we always write out the formula, fill in what we know, and solve for what we don't know. You always want to use these helpful hints as well. Make sure you cube or use the cube root when we're dealing with spheres, while we square or use the square root when we're dealing with cones and cylinders. Include units, and do not round until the final answer. Before concluding the video, I want to mention that you may see problems like this. Although they may or may not be in your notes, you could see problems that are not as straightforward as just asking for the volume of a cone, a cylinder, or a sphere. In this first problem, we see half of a sphere, or a hemisphere. So you could imagine that there was a full sphere here, find the volume, and then divide it by 2, or multiply it by a half. In the next problem, we see a cone, and then we also see half a sphere. You would have to find those two volumes separately and then add them together. So there are some problems that will require you to do a little more thinking than just finding a formula and filling it in.